So you're welcome to Master T Math class. And in this live class, we want to continue from circle geometry, and we look at some questions on it. Circle geometry. And before we consider some questions, first, let's look at the summary of the theorems that we have. So we have theorem 1. So let's list out those theorems. Angle at the center is twice the angle at circumference. So we can use diagram to represent this. If this is the center of a circle, center hole. So angles obtained by a chord or might be an arc at the center here. This angle is at the center and it's twice the angle at the circumference here. So if the angle at circumference is x, angle at center here is 2x. And this angle is also at the center, and we can have its angle at circumference at this side. So if the angle at circumference is y here, then this other side is the angle at center, which will be 2y. So let's take note of that theorem 1. And also theorem 2. We have angle in the same segment are all equal. Let's look at this circle. And looking at this as the center of the circle, O, and we consider a chord as well. Let's say chord AB. So angles obtained by this chord in the same segment are all equal. So all this angle here formed by this chord are all equal on this theorem. So that's angle in the same segment are equal. This angle is equals to this angle is equals to this angle. So if this is x, this will be x, and this will be x. So let's take note of that. We just want to look at quick recap of those theorems. So in our previous classes, we have looked at those theorems in detail. So you can just go to our live section and check out those videos. And next, we looked at angle in a semicircle is perpendicular, that is its right angle, which is angle 90 degrees. Let's say this is the center of the circle, and we have a diameter. The diameter passes through the center. So, and that makes this circle to be divided into 2 equal halves, which is called semicircle. So angles obtained by this diameter here is therefore a right angle. So angle 90 degrees. So it doesn't matter how it is drawn. It might be in another way, in another form. This is center. The diameter might be like this. Once it is passing through the center is the diameter, and any angle formed by that diameter is angle 90 degrees. So even if it's not stated that it's 90 degrees, we are going to know since we have a diameter and the angle is formed by the diameter. So we take notes of that as the theorem 3. Then in the same way, we looked at another one, which is our theorem 4. That's a line drawn from the center of the circle to a chord. So we have a chord AB and we have the center of the circle. So the line drawn from the center of the circle to this chord is perpendicular to this chord. So we looked at that in detail as well in our previous live class. So that when we join this center to point A and also the center to point B, this will be radius, this will be radius. And therefore, we have 2 similar right angle triangles, so we can solve any of them using the Pythagoras theorem to find whichever side is missing. And it is important to note that this chord, this line also divides this chord into 2 equal halves. That this line AN is equals to line BN. So just a recap of our theorem. And let's look at the 5th theorem. And in the fifth theorem, we have the opposite angles of a cyclic collateral as supplementary. So what a cyclic collateral is simply a quadrilateral that is inscribed in a circle. A quadrilateral has four angles. So all the four angles must touch the circumference of the circle. That's meaning of inscribed. So when we inscribe a quadrilateral inside a circle, so that is what they call a cyclic collateral. So the opposite angle of a cyclic collateral are supplementary. So let's label this angle as A, B, and this angle as C, D. So what this theorem is saying is that angle A plus B is equals to 180 degree, and also angle C plus D is equals to 180 degree as well. So opposite angle of a cyclic collateral are supplementary. So now theorem 6 is an extension of this theorem, which says the exterior angle of a cyclic collateral. So when we have a cyclic collateral and one of the side is extended, let's extend this one here. So this is exterior angle here, and this exterior angle is equals to the opposite interior angle. So if this is angle A and this is angle B, what this theorem is saying is that A is equals to B. So these two angles here, we have the same values. So that's what this theorem is talking about. Now, if we want to be able to solve question easily on circle, there's need for us to master these theorems and know how to apply them. Now, also, the seventh theorem here is on tangent theorem, and similar to what we have in our theorem 4, just that in this case, it's not a chord or it's a tangent. And tangent touch a circle at a point. So tangent is a line that touches a circle at a point. And from the center of the circle, now the theorem says that a line drawn from the center of the circle to the point of contact of the tangent is perpendicular to the tangent. So a line drawn from the center of the circle to the point of contact of the tangent is perpendicular to the tangent. So in other words, that means the angle between the radius and the tangent is right angle. So because a line drawn from the center to the circumference here is the radius, it might be in another way. So if we have the tangent this way, and you have a point of contact here, now you have the center. The line from the center to this place is a radius. So which means angle between radius and tangent is 90 degree. So that is for theorem 7, which is tangent theorem under the tangent theorem. Okay, so we have two more tangent theorem, which is also very useful. So let's yeah, we have two tangent theorem as well left, and we call that theorem 8. And theorem 8 says that the angle between a tangent and a chord. So when we have a tangent and at the point of contact a chord is attached, so angle between this tangent and this chord, he said that angle is equal to the angle in the alternate segment, as is this other part. So that means an angle is formed by attaching two chords with this chord. So angle between these two chords now is equal to the angle here. So that theorem also is very, very important. So we need to understand that. So if this is A, this is B, it means that angle A is equal to angle B. And let's look at it in this side as well. So if this is the tangent and this is a chord, angle between this chord and this tangent is also equals to the angle between these two chords in the other segment. So if this is C and this is D, it also means that angle C is equals to angle D. So we have this as theorem 8. Actually, we looked at this in detail in our previous classes. So You can do it to check our live classes. Just check our page and the live section. You see the videos on them. Just click on them and watch. Then we are just looking at the recap. So as for us to solve some question. And we have the last theorem here, which is theorem 9. And that theorem is also on tangent. Now, when we have a circle with center hole and two tangents come from an external point. So let's say we have this tangent and this tangent that is from an external point P here. So the theorem is saying that these two tangents are equal in length. That's the first thing. And also, don't forget that from this theorem here, a line drawn from the center to the point of contact, this center hole, to the point of contact of this tangent is perpendicular to this tangent. And also same thing here, if you draw a line from the center to the point of contact here, it is perpendicular to this tangent. And the next one is that a line drawn from P to O. So if we draw this line from P to O, this line will bisect the angle between P. So assuming the angle between P is 50 now, so it will now be 25, 25. Bisect in mathematics means to divide. So bisect means divide into equal parts. Divide into equal parts. So this line bisects this angle between P into equal parts. So if this is A as well. And also bisect this angle at the center here. If this is B, this is B. So this theorem will help us to solve questions under circle theorem. So next now we are going to be looking at some questions and applying one or two theorems to them to solve it. So stay tuned to the end of this class to enjoy it to the end, and also give a thumbs up and share this video. And if you are just joining us in this channel, why not be part of us? Just subscribe and also join our membership package. All right, now let's solve some question now. That is, here we look at the first question here. We have question 1. We are given the circle like this with the center even here, even the cyclic collateral, something like this is drawn inside that look like, say, should we call it a kite or what? But it's a collateral inscribed in the circle. And this line is joined together this way from here to here. And this line, something is put here, a symbol put here, and they label this as A, and they label this angle as 90 what? That's 94 degrees. So this angle is labeled as 94 degrees. And what happened? The question says you find the value of angle A. Now look at this. Whenever we see similar sign on two lines, it means that those two lines are equal in mathematics. So we have same sign on the line. What it means there is that these two lines are equal in length. And don't forget that whenever we have a triangle and two sides of that triangle are equal, like this triangle is called an isosceles triangle. And for an isosceles triangle, we always have the base angle as well to be equal. So the third angle, the third side is the base, and the angle at that base are also equal. So this angle is A now, this angle also will be A. That's what happened here. So if this is A, this is also A. Now, how do we get that? Looking at this shape now, we have a cyclic collateral, and there is a theorem that says that the opposite angle of a cyclic collateral are supplementary, So you can decide to put x here. That means x plus 94 degrees should add up to 180 degrees. So if someone do not know this theorem, it will be difficult to solve this problem. So that is why if you want to be able to solve question on circle, first thing is to master those theorems and know how to use them. So x equals to 180 degrees minus 94 degrees, which implies x equals to, we have it what? 86 degrees here. Are we there? And here, if x is now 86 degrees, it means that 86 degree plus a is sum of angle in the triangles. That is, the three angles there sum up to 180. And a plus a, that's 2a, then plus 86 degrees, now equals to 180 degrees. Also sum of angle in a triangle. So take 86 degree here. So it's give us 2a equals to 180 degrees minus 86 degree, and that's also 94. So 2a equals to 94. Now, divide both side by 2 to get your a now, which implies 2 cancel each other here, and we have a equals to, that's 47 degrees. So that is how to handle this problem. So we just applied a theorem coupled with the property of the triangles that we know, which is isosceles triangle. So that is question 1 here. Now consider the next question, which will be number 2 here. Given this circle, with center O here, and a line passed through the center and extended outside, and here we have an angle drawn here from this line that passed through the center, and from here also we have this line coming here, joining this one and meets at this point, and meeting here as well to form another angle. And here we put the same symbol on this line, and we call this angle 36 here, 36 degree. We call this angle 25 degrees, and here we label this as F, this as E. And the question says here we should find angle E and F. So find the value of angle E and F. Now let's look at what is given here. We should be able to see that here is the center of the circle, and this line here is a diameter. From this angle here to this angle, we have a diameter. An angle formed by a diameter, don't forget, that's angle in a semicircle. If you have a center and you have a diameter, angle formed by a diameter should be 90 degrees. So here, this angle here is 90 degrees. That's what we need to see first. So we need to establish that this angle here is 90 degrees. And actually, we can get the value we are finding, anything we are finding, we can use any method and get our result. All right. It depends on what we can see. It depends on what we can see. Okay. So somebody might say that, yeah, these two signs input here has a meaning. The same way with what we have the other time. When two sides are equal in a triangle, look at that triangle, something like this. They said this side is equal to this side. Okay, and this angle is 36. Definitely, this angle is also what? 36 degree. That's base angle of our triangle. Now, let's consider here as 36 degree now. But something interesting happened here. we have this line is a straight line, and 36 lie on the straight line, 90 lie on the straight line. This angle too lie on the straight line. So let's label this angle as x. We can get that now because the three angles on a straight line. It means they must add up to what? 180 degrees. And that means we have x plus 90 plus 36 equals to 180 degrees, which makes it, x equals to 90 minus 36 now. I believe we are there. So here, taking 90 from 180, that's 90. So 90 minus 36. So that means x equals to, we have 54, right? 54 degrees. So x is 54 degrees. Now, look, considering this triangle here we have, there's something interesting here that we need to see. We have this triangle here. Look at it. The way it is like this. And this side now, this line is drawn and extended outside. We got this as 25 degrees. We got this as 54 degrees. Yeah, this angle here seems like an exterior angle of this triangle now. And that's why we need to understand the property of triangles very well. An exterior angle of a triangle is equal to the sum of the two opposite interior angles. So it means E now will be equals to, so we can say angle E is now equals to 54 degrees plus 25 degrees. And that gives us 79 degrees, right? So we are good to go. What happened next? We got this at 79 degrees already. So we don't have much time to waste again. So to get F now, very easy. Consider this triangle 79, 90, F. So sum of angle in a triangle also is what? 180 degrees. So that means we have F plus 90 degrees plus 79 degrees is equals to 180 degrees. So when you subtract 90 from 180, that's 90. So F is now equals to 90 minus 79 degrees. And that gives us what? That's 18, right? So that's 18. Oh, sorry. That's 11, right? That's 11 degrees from there. All right. So that is how to handle this such problem here. So we appreciate you for connecting to this class. This is Master T Math class, the home of mathematics. So what we do here is we solve mathematics. Why not be part of us by subscribing and also join our membership package? We have different packages. So just join any package of your choice so as to have access to exclusive perks, and also share this video just to make it reach out to more viewers. Now let's look at number 2 here. So number 3 question, we have this diagram given, which is also an interesting one. Look at it. We have this shape. It's in form of a quadrilateral inscribed in a circle. So we have it this way. You might say it's a kite, or it's a quadrilateral inscribed in a circle, and the center is indicated here actually, and this angle is labeled as 3K. This angle is labeled as 2K. Then the question says we should find the value of K. This is just a fast one for us to handle. It's a fast one. It's a fast one actually. So just by knowing the principle that guide this, we are done. Because this is a cyclic quadrilateral, opposite angles sum up to 180. So therefore, we can say 2K plus 3K here will be equals to That's opposite angle of a cyclic quadrilateral. This is 5k now, equals to 180 degrees. So divide both sides by 5 to get k. So you divide both sides by 5. 5 cancel each other here. Here k equals to 3, then 6, right? So that's 36 degrees. We have it like that. So that is what we have in this particular question number 3. All right. So now let's consider another one, which is also an interesting question here. We have this diagram. It's number 4. Given a circle, something like this. So we have 1, 2, 3, 4, 5. Something like 5-sided shape, like a pentagon. 2, 3, 4, then 5. Then here we are giving this angle to be 116 degrees. These two sides are equal, have the same symbol, and this angle here, we say is 100 degrees, and find the value of y. Now, whenever we see something like this, that these two sides equal, we can derive something out here. Actually, when you look at this, it's not a quadrilateral. So we can't say opposite angle is cyclic quadrilateral. We cannot add this and say it is 180. No, because this is not more a quadrilateral. It has become a pentagon, right? Now let's construct a line from this angle here to this angle by joining these two angles together with a construction line. Don't forget that the whole of this angle here is given to be 100. Okay, so everything here is 100 degrees. But something interesting is here now. From this now, we have already cut out a triangle here. And from this triangle here, these two sides are equal, which makes this angle to be equal. It makes it an isosceles triangle if you have been following the class. So this now can be labeled as x. This is also what? X. Are we there now? So here, we can find the value of x by saying x plus x, 2x plus 116 should be equal to 180 degrees. That's sum of angle in a triangle, right? And taking 116 here, we have 2x equals to 180 degrees minus 116 degrees. So just take it away, and that gives us 64, right? So 2x equals to 64. Then divide both sides by 2. So x equals to 32, okay? Now, if x is 32, it makes this angle here to be 32. And everything is 100. Now, subtract 32 from 100. This one will give us what? I think that's 68, right? Yes. So this angle was 68 degrees now. I hope you understood it. So this angle is 32 and everything is 100. Then we must have 68 here. So also this is 32, right? Now we are fine. Looking at this shape now, we already have a cyclic quadrilateral now. Looking at 4 angles, 1, 2, 3, 4. It forms a cyclic quadrilateral. So we can add these two angles together now and say they are equals to 180 degrees. That's opposite angle of a cyclic quadrilateral. So therefore, we have y plus 68 degrees equals to 180 degrees. That makes it opposite angles of a cyclic quad. And what's happening? Taking 68 here, we have y equals to 180 degrees minus 68 degrees. And that gives us what there? That's 2. That's 112, right? Are we? Yes. That's y equals to 112 degrees. So that is how to handle this kind of problem in this question. So I believe you are enjoying this class. Why not support us here by giving us your like, your sharing, and also subscribing so that you will stay tuned and we don't miss our classes. All right. Now here we have another one which is going to be number 5 here in this particular class. So we have it as question number 5. And here we also have a circle. And inside the circle, you have something like a circumcollateral in form of let's say a kite, something like that is drawn inside here. But a side is prolonged, is extended outside. So this is joined now to form a cyclic chord. And here we are given these two sides equal, and a line connects these two angles together. So they make our work easier there. And they indicate that here is the center of the circle. Alright. And this angle here outside is labeled as 96 degrees. And here we have an angle here, which is angle A. And this angle here is angle B. Now the question wants us to find the value of A and B, right? And also here, this is indicated a symbol. It's also here, like this. Now let's look at this. From theorem 5 or thereabout, which is extension of theorem from theorem 6, which is extension of theorem 5. What I mean is that we have extension of opposite angle with cyclic collateral. That says whenever we have a collateral inscribed in a circle and a side is extended out this way, this angle is exterior angle and is equal to the opposite interior angle. So we don't have to waste our time. Once we see that this is extended, this is 96, that means here also will be 96 degrees. Why? It's a cyclic collateral which is extended. So that's the purpose of this theorem. Are we together there? And something interesting happen here. Whenever we see two sides equal in angle, it makes it an isosceles triangle. That is it. Why? Because in an isosceles triangle, two sides are equal. And therefore, the base angle are equal. Now, they call this angle as B. Definitely, this angle is also B. So easily now, we can get B by adding B plus B. That's 2B. Then plus 96 degrees. We now sum up to 180 degrees. Why? Sum of angle in a triangle. Right? Sum of angle in a triangle. So just take 96 here and say 2B equals to 180 degrees minus 96 degrees. That means 2B equals to, that should be 84, right? So we have 84 degrees. Now, what happened? Divide both sides by 2. B is now equals to 42. Okay? Now, if B is 42 degrees now, looking at what we have now, B is 42 degrees and also 42 degrees here. Then we want to find the value of A. To find the value of A here easily, even we might not need to stress ourselves again. We already gotten B. Two things we are finding. We are finding B. B is gotten. Now, how do we get A? Also come here. This is a straight line. Any one you use you can use a straight line, angle on a straight line, add up to 180 degree, or you can say opposite angle with exactly collateral, add up to 180 degree. It gives you the same thing. So just subtract 96 from 180, and that's 84. It makes this angle 84 degrees, right? Now, what happened next? This angle is 84 degrees, and look at this sign. A sign on this line, also a sign on this line. It also made this triangle here, which makes this triangle here to be an isosceles triangle, and this angle is 84. This angle also is 84 because it's base angle. Are we following now? So it's a base angle, and now we can get the value of A. How? By adding this 84 plus 84 plus A will be 180 degrees. So we can now say A plus 84 degrees plus 84 degrees is equals to 180 degrees. That's sum of angle in triangles. So whenever we have a triangles, the angles there sum up to 180 degrees. Now add this together. This gives us 168, right? So A is now equals to 180 degrees minus 168 degrees. So which makes A to be equals to, this gives us, that's 12, right? Are we? So that's 12 degrees. So that is how to handle this kind of problem. So once we know those theorems, it will stand as a guide for us. So I believe you enjoyed this class. Stay tuned as we'll be uploading videos. We upload videos daily, so you can watch some interesting one that you want. And also our live classes here. Also we come live daily, which is going to be interesting as well. So why not subscribe and turn the notification bell on, and also join our membership package. Share this video, give it a thumbs up, and subscribe, and stay tuned. See you next class. Bye for now.